Alright, so let's check it together first with the h of x. The root I'm trying is 1. I did the synthetic division over here. Once, twice, third times I got the remainder of 5, so that means it's only going to be a factor twice, meaning multiplicity of 2. So I got x minus 1 square. That square means the zeros twice, multiplicity 2. And then times your quotient, 2x plus 3. This part, I did not ask you to do it. I mean, the problem did not ask you to do it, but I think it's a good practice, so I'm going to keep doing it. Describe the behavior at that 0. The graph is tangent to x-axis at x equal 1, as you can see right there. Okay? Alright, next one. I did the synthetic division. I did 4 in total. The last one I got the remainder of 9. That means it's only going to be the factor 3 times multiplicity of 3. So x minus 2 cubed times the quotient 2x plus 5 multiplicity 3. Describe what happened at 2. Right there. The graph crosses the x-axis at x equal 2 and changes the concavity. It's the same description we use when it has a multiplicity of 3. Okay? Alright, now let's consider how we might be able to locate the zeros of a polynomial function numerically. Look at the last page. Consider the function h of x that we investigated earlier, whose graph is shown below. Find each pair of the function value in the table below and answer the question that follow. Alright, just ask me to find things. So first, let's find h of negative 2. I'm not sure I should use the graph or... let's use the equation. Okay, h of negative 2. Take negative 2, plug in where x's are. So 2 times negative 2 cubed minus negative 2 squared minus 4 times negative 2 plus 3. Let's see, negative 2 cubed is negative 8 times 2 is negative 16. Negative 2 quantity square is 4, and then you put minus in the front. Negative 4 times negative 2 is positive 8, and then plus 3. I get negative 12 plus 11, negative 9. Guest teacher, can you pause the video and let students find h of negative 1, h of 0, h of 2 quickly, and then resume back once they find those 3 values. It should take about 2 to 3 minutes. Okay, so this is what I got. H of negative 1 I got 4. H of 0 I got 3. H of 2 I got 7. And hopefully that's what you got too. From the graph, clearly h of x has zeros between x equal negative 2 and negative 1, which is right here. Explain how your finding of the value of h of negative 2 and h of negative 1 above numerically shows that there is a 0 that exists between x equal negative 2 and x equal negative 1. Okay. Alright. H of negative 2, y value, we got negative 9. And h of negative 1, we got 4. Okay, so guys, just visualize it. H of negative 2 was at negative 9 right here, under the x-axis. And h of negative 1, I got y value of 4 above the x-axis. And it's continuous. So it went from negative y value to positive y value. Would you be able to predict that that means a 0 is going to exist between those two? Because it has to pass x-axis somehow between those two values. Does that make sense to you? Yes, so we're just going to say h of negative 2 is 0 and h of negative 1 is greater than 0, which means it should pass x-axis sometime in between. And it makes sense. So there is going to be 0 between x equal negative 2 and x equal negative 1. Okay? Alright. Does the same reasoning you described concerning zeros between x equal negative 2 and x equal negative 1 hold true for the existence of 0 between 0 and x equals 0 and x equal 2? Well, let's see. H of 0 we got 3 and h of 2 we got 7. Okay, so just visualize it. X equals 0 was 3 here. X equal 2 is 7 here. Alright, so one was positive y, the other one was positive y. Does that give you enough reason that zero is going to exist between those two? Well, we don't know that. What if they're just connected straightforward? Then there is no 0. Obviously, if you look at the original graph, it like bounced back down and hit the x-axis at 1 and then going up. So I know a 0 exists between those two, but what if it was like this? Like just a positive to positive y. So we just said no, not sufficient. It's only true if one is negative and one is positive and vice versa. Then a 0 must exist between those two. Alright, based on what we have seen, what interference can you make about existence of 0 of a polynomial function if you know the value of function at two different x values? 0 exists if two y values are opposites. So going from positive to negative or negative to positive, like what we saw over here. Alright, table of values, oops. It's a cubic function. Okay, circle the word cubic. The function is negative 0 and 2 positive zeros. Okay, answer the following question. Alright, so the graph is, the table is given to you. The tops are the x values and the bottoms are the y values. Some of you should be able to visualize this just by looking at the numbers. Like for example, you know, this means negative x, negative y, so somewhere here you start, and then, and yeah. So let's do it. Alright, negative 2 and negative 45, negative 1, at negative 8, at 0, y value 3, at 1, y value is 1, at 2, y value is negative 5, at 4, y value is 27, and 5, y value is 88. So it's going to look like something like this. Obviously not exact, but kind of. All I do is kind of draw this as a rough sketch of it. And make sure it makes sense. Cubic function. Yes, it does look like cubic function. 1, 2, 3. 1, negative 0 right there. 2 positive zeros right here. Alright, answer the following. Is there any 0 f of x specifically identified in the table? Yes, there is. Do you see one? Which one? Right here. X equal 1. Why is that a specific 0? Because y value is what? 0. And that exactly is the definition of zeros, right? So x value and y is 0. X-intercept. Between which two x values in the table is negative 0 located? Explain your reasoning. So you should be able to use kind of thinking that we did on the examples on the top. A 0 exists if two y values are opposite. So the second row is the y values. Where's the negative 0? Well, let's see. When x equals negative 1, y value is negative 8. So it's going to be underneath it here. But when x equals 0, y value is 3. So y value went from negative y value to positive y value. So we're going to say between x equals negative 1 and x equals 0, that 0 exists. Why? Because it changed the sign. it's going to be right here, between x equal -1 and x equal 0. Between which two x value is a table, second positive y is the second positive x located? I'm going to give you some time to think about it. In fact, guest teacher, give them 1 or 2 minutes to think, and then we'll work together. Okay, so let's go over together. Where's the second positive 0? If you look at these two values right here, when x equal 2, y was at -3 underneath it. But then when x was 4, y value jumped up to 24. So it crosses the x value. It crosses the x-axis between these two. So between x equal 2 and x equal 4. Because y went from negative to positive. Okay? Alright, so that is it for the lesson. Not really difficult lesson at all. Just needed to make the connection. Now please receive 2 things from the guest teacher. Skill 15 IP. It says Skill 15 Independent Practice, which is due Thursday. And work on that the rest of the class time. And you're also going to get the assessment number for Skill 11 through 14 review IP, but you have some time to work on it on Thursday, so just hold on to it. Okay? Alright. I will see you guys later. Good luck.